In this first video, we're going to look at a brief introduction into statistics, a discussion of some terminology, and then we'll talk about different kinds of sampling methods and what types of errors may arise as we take samples. So first of all, what are statistics? What comes to mind when you hear that word? You may think about numbers. You may think about graphs, data, and that's all true. If we're to look at a definition of statistics, we might see something in the order of, it's the science of collecting, organizing, presenting, analyzing, and interpreting data in order to assist us in making more effective decisions. Now, in this definition, it sort of nicely breaks down some of the key components of this course. You'll see that especially in Unit 1 and in most of Unit 2, we'll be talking about the first part of that definition, collecting and organizing, presenting, analyzing data. And then really the second half or the back half of this course is all about using that information that we've collected and we've organized in order to help us make a more effective decision. Should we make an investment? Do we believe our machinery is working properly? And the difference between the two halves of the course, if you will, is really the two different types of statistics that there are. When we talk about statistics, we may talk about descriptive statistics or inferential statistics. Now with descriptive statistics, here's where we're taking just a bunch of random numbers and sort of organizing it into something that makes sense, something that we can make an interpretation out of. The inferential statistics is actually using that information in order to help us make a better decision about the population at large. So with descriptive stats, we're talking about things like doing frequency distributions, what you'll see in our next lesson. Calculating the mean, median, mode, our measures of central tendency. Calculating range and standard deviation, some of our measures of variability. As I said, this really encompasses the first part of the course. And then moving on to the inferential statistics, here we're looking at a bunch of the topics that we'll see later on, starting in Units 3. Confidence intervals, hypothesis testing, regression analysis. So descriptive stats, organizing that information so that it makes some sort of sense, and inferential stats, using that organized data from our sample to help us make estimations about a population. We have two methods of data collection that we will talk about. There is primary data and secondary data. Primary data is data that you actually go out and collect. Secondary data, you're using data that's already been obtained by somebody else. While there are advantages and disadvantages to both of these, an advantage of primary data is we can set up our surveys and our questionnaires to collect exactly the data we need, and we can phrase those questions to be most meaningful to our study. An advantage of secondary data is that it's much quicker and much cheaper to obtain. We don't have to take the time ourselves to go and do it. Disadvantages for each. Well, primary data, it can be quite costly or time-consuming to go and collect data on our own. And in terms of a disadvantage of secondary data, we really have to be careful where the source of that data comes from and what methods of collection they've used. Now, it should be pointed out that these are definitely just a select few examples and that there are many other advantages and disadvantages to each primary data and secondary data collection. Some definitions of terms that will come up as we go through this course. Two that we'll definitely see quite frequently are population and sample. Anytime you hear the term population, that will refer to the entire group under study. Now, that entire group will be set out by the parameters of our research. So for example, if we're talking about this class specifically, the population would be all of the students contained within this class. A sample is a subset of that population. So in this case, we're not talking about every single student in the class. We may be simply talking about 5 randomly selected students. The next definitions we'll look at are for parameter and statistic. Anytime we hear the term parameter, that will refer to a summary measure of data from a population. A statistic is a summary measure of data from a sample. For example, in the not too distant future, we'll be calculating values for the population standard deviation or the sample standard deviation. So if I was to talk about the population standard deviation, that would be referred to as a parameter. If I was to talk about the sample standard deviation, that would be referred to as a statistic. And lastly, we've already used this term in this lecture, raw data. All we mean by the term raw data is when we have data that's been collected, yet it hasn't been organized in any meaningful way yet. We haven't done anything with those numbers. Looking now at samples and why we would take samples instead of values from everything within the population, different types of sampling, and errors that can arise. First of all, the purpose of sampling is when we are taking samples, we are going to use that sample in order to draw conclusions about the population as a whole based on the data that we've gathered within that sample. Now, if you remember, this is one of the types of statistics that we were talking about. 2 types of statistics. One where we simply gather data, crunch some numbers, organize it in a meaningful way, known as descriptive statistics. And this type of statistics, where we're making conclusions about a large population, known as inferential statistics. Why would we bother taking a sample and not simply all the data from the entire population? Well, there are a number of reasons why we may do that. It may simply be that we don't have enough time to take data from the entire population. And maybe that we don't have enough money. A lot of times what we'll find is that the sample results are often enough. They allow us to make accurate conclusions about the population anyways. There may be limitations, either physically or geographically, which prevent us from taking data from the entire population. Or there may be something known as destructive testing. So, for example, if we're doing quality assurance at a car manufacturing plant, we want to be certain that our vehicles are safe. So every now and then we'll take a vehicle from our production line and we'll put it through a crash test. Well, after we've put the vehicle through the crash test, it's really not possible to go and sell that vehicle. So anytime we do a test on our product that renders it useless and not able to sell, that is known as destructive testing, and it wouldn't make sense to do that to the entire population, because if I went and crashed every car that was coming off the assembly line, we'd have nothing left to sell. So in cases like that where destructive testing is necessary, we would absolutely have to use data from a small sample and not the entire population. 2 types of sampling that we'll look at are non-statistical sampling and statistical sampling. Non-statistical simply might be that elements are chosen for our own convenience. In order to be considered statistical sampling, we cannot choose items for our own convenience, but elements absolutely must be chosen at random. Now, with non-statistical samplings, we cannot necessarily always extrapolate the data from that sample and apply it to our population as a whole. The only time we can make those inferences about the entire population is when we use statistical sampling. Well, let's look at a quick example here. If you go to the Globe and Mail or many other websites, what you often find is that there's a poll that website is running. Okay, on the day that I'm recording this video, they have a poll asking how much network television do we watch. Okay, either a lot, my fave shows are on networks, I watch a bit, I watch a lot of cable too, hardly any, I watch mainly DVDs and downloads, or I don't watch TV at all. I will select a bit in order to participate in this poll and submit my vote. And I'll be able to see that there are several people who have participated in this. Okay, we have a few thousand votes showing that 14% have responded a lot, 32 have responded a bit, 31 hardly any, and 23 say they don't watch TV at all. Now here a sample has been taken, but is that sample a non-statistical sample or a statistical sample? Can we go and make assumptions about the entire population based on what we just did? And the answer to that question is what we just participated in was definitely a non-statistical sample. If we look at what the difference between these two things are, remember, to be considered a statistical sample, items have to be randomly chosen. Anytime you are participating in an online poll, it is absolutely impossible that that is a random sample. What I just did, there's only a very select group of people that would go to the Globe and Mail and participate in their poll. That is definitely a non-statistical sample. I'm not going to get an accurate cross-section of the entire population of Canada. So randomness is the key in the distinguishment between statistical and non-statistical. So why would we bother taking non-statistical samples if we can't make assumptions about the population from them anyways? Well, they can be quite useful in various things. In terms of testing questionnaires, learning about emerging trends, testing new products. Focus groups would be a good example of this. Some terms that we might see dealing with statistical sampling are the frame, which is a list of all the elements within a population. Simple random sampling means that each and every one of those elements within the population is equally likely to be selected as a participant within the sample. There are two types of errors that may arise as we do sampling. One of those types of errors is known as sampling error, and sampling error is the difference between the actual value of the population parameter and the value of the corresponding sample statistic that we've gained from our sample. Now, this type of error will always arise because no matter how good we set up our sample to be, it will never perfectly reflect the population. Sampling error will always exist. It is absolutely impossible to eliminate. So remember, as we take a sample and we calculate the sample average, we would not expect that if we took values from the entire population, that the population's average would be the exact same value as the sample's average. Now we can minimize that error through various methods that we'll learn later on in the course, but it should be remembered that sampling error will never ever be eliminated, and there will always be a slight discrepancy between any sample statistic and its associated population parameter. However, within sampling, there are some errors that we can eliminate, and those are known as non-sampling errors. Non-sampling errors arise as a result of mistakes or inaccuracies as we are doing sampling. There are 5 main types of sampling error. So the first one we'll look at is coverage. Coverage error simply means we have inaccuracy within our survey frame. Now remember, a frame was a list of all the possible elements within a population. So if our frame doesn't contain all the elements within the population, we've set ourselves up for error right off the bat. Non-response error is when for some reason we can't collect data from an individual within that population. A response error is now we've actually obtained a response from one of those elements within our frame, but for some reason that element's response was inaccurate. Now that can happen due to several reasons. We might have within our questionnaire a question that's misleading. The interviewer may impose bias upon the subject. The respondent themselves might not want to answer the question and intentionally responds inaccurately. We may have processing errors. This can be something as simple as the data entry of our values. So we've taken a survey, it's on a piece of paper, and as we go to input it into our computer software, we incorrectly type in what the value from the respondent was supposed to be. An estimation error is where we actually go and make inaccuracies within our calculation. Either we're using incorrect formulas or we have simply done the mathematics within the calculation improperly. With every lesson we do, we'll be doing some work within Microsoft Excel. So what we want to do within this example is to take a statistical sample of 7 randomly selected locations. Now remember that idea of randomness is what is crucial in order to get a statistical sample. We don't want to simply choose these 7 locations that are closest to us because that means we have to drive the least amount of distance. If we did that, then we would have a non-statistical sample. We had chosen 7 locations based on something that was convenient for us. So here, we want to use something so that we have a completely unbiased random sample. Now what we can use to do that is the random function within Excel, which will give us a list of random numbers. So if we look at our question, we have a whole bunch of locations, and we're going to say that this is all the Tim Hortons locations within London here. And with each of those, we would like to associate a random number. Now, one way we can find functions within Excel is to look at the top of the Excel window, and we'll see there are different tabs that I can select. And one of those is formulas, and within my formulas tab there is a whole bunch of different options that we have to choose from. You'll see that many of the functions we use in this class can be found under the More Functions and then Statistical. There is a whole list of statistical functions to choose from. Now we definitely will not be using all of those, but we will use some. For the purposes of this example, we want to use a random function, and what you'll notice is either whether you hunt for your functions through the different categories, or we simply want to create a function on our own, any function we use will start with the equal sign. So I'm going to start by hitting equals, and I know the function that I want to use here, so I'm just going to type it in. And you'll notice every time I type a letter, it will create a list of possible functions that start with that letter. So the one that I want is rand. And if I look at what it tells me that random function does, I'm going to hit my little function icon here now that I've typed rand in. And that will bring up a function argument box for me, and it'll tell me exactly what the purpose of the function is. It tells me that this function returns a random number greater than or equal to 0 and less than 1. So this is the function that I want in order to create my random number. I will hit OK. And at this point, I have my first location of 670 Wonderland Road North and its associated random number. Now what we want to do is to make sure that every location has a random number associated with it. So I'm going to copy and paste that formula that I just made, equals rand, to each and every other location. We can do that in 2 ways. I can simply go to the bottom right corner of that cell, and notice where my icon changes from a thick white plus to a skinny solid black plus sign, and I can either drag that function down and it would copy it to all the other cells, or we can simply double click on that bottom corner. As long as the cell immediately to the left of that value has something in it, it will copy that function over. So you'll notice as soon as I hit my first blank cell to the left, it stopped copying and pasting that function. Okay, well here we have each of our locations with a random number associated with it. And now what I want to do is to sort my different locations based on these random numbers. So what I'm going to do now is to highlight all of those locations and their random numbers. And I'm going to go up to my Data tab at the top of the screen. So click on Data, and I want to do a sort. So these first sort icons we can use if we're simply sorting within one column. Here we're going to sort over multiple columns. So I want to use this multi-column sort function. And if we look here, what are we going to sort by? Well, we want it to sort by the random number itself. So the value in column B. I don't want it to sort by column A. If I do that, it will simply put the locations in order of their address number. So we're going to sort by the random column B. We want it to sort based on the value in that column. And it doesn't matter whether we say smallest to largest or largest to smallest. As soon as I hit OK, it's going to sort based on the current random number that is in that column B. So I'll hit OK. And now it's created a totally different random list based on what those random numbers were before. So I have no influence over what the first 7 locations selected were. And I can simply highlight my first 7 locations, and these would be the 7 stores that I would select for my random sample. So we had no influence over what those stores would be. We use the random number function in Excel to create that random list, and we can now do some statistical sampling. Now some of you may have noticed that it doesn't appear that these seem to be in order anymore, which they're not. It is a feature of the random function within Excel that every time you make an input, the random number itself changes. So if I was to put anything in another cell, for example, if I hit 1 here and enter, it will change all of those values within the cells again. Now my locations haven't changed. They were still sorted based on what those first random numbers were, but the random numbers every time I put in a new entry will update and change.